no, we will forego with the checking of attendance. It takes a lot of time. But anyway, once you are requesting for admittance, I normally record already the students who are being admitted, no? So we will forego with the checking of attendance. Okay. Now our lecture for today is abstraction or losses from precipitation. And we first discussed the one. We can say that in losses from precipitation, no? In engineering hydrology, runoff due to a storm event is often the major subject of the study. No, so runoff is the major storm event. Runoff refers to the water that are already on the ground, flowing on top of the ground. Then the abstraction from precipitation are evaporation, transpiration, infiltration, surface detention, and storage, and these are considered as losses in the production of runoff. Evaporation from water bodies and soil masses together with transpiration from vegetation is termed as evapotranspiration. Interception and depression storage are considered as losses in the production of runoff. Infiltration process is a major abstraction from precipitation and an important process in groundwater recharge and in increasing soil moisture moisture storage. So in this case, we can simply say that wait a minute now. Wait a minute. I'm just going to receive a phone call. Okay. Now, with regards to the first one, we will now continue. No, can you hear me? Hello, hello.
Yes, sir.
Okay. With respect to the first one, you have evaporation. When we speak of evaporation, it is the process in which a liquid changes to the gaseous state at the free surface below the boiling point through the transfer of heat energy. Consider a body of water in a pond as an example. So everybody knows what evaporation process is. And in evaporation process, the second paragraph says, the molecules of water are in constant motion with a wide range of instantaneous velocities. An addition of heat causes this range in average speed to increase, with some molecules possess sufficient kinetic energy and they may cross over water surface. Similarly, the atmosphere in the immediate neighborhood of the water. Surface contains molecules within the water vapor in motion, and some of them may penetrate the water surface. The netscape of water molecules from the liquid state to gaseous state constitute evaporation. And evaporation is also a cooling process in that the latent heat of vaporization at about 585 calories per gram of evaporated water must be provided by the water body. As what you can see in the figure here, you are given here uh, a picture of the hydrologic cycle process, wherein at least it is related to evaporation and evapotranspiration through the introduction of radiative exchange, the transport, condensation, because of latent heating of the atmosphere, and then the boundary layer, land in exchange with the atmosphere, the ocean. And in this case, we can expect that the moment there is transport of heat coming from the sun, expect that there will be evaporation. Like the water vapor rises into the atmosphere from oceans, from ponds, from puddles. So these are examples of direct precipitation. And if we consider in a container an aerosol of microscopic water droplets suspended in the air above the hot tea cup, after the water vapor has sufficiently cooled and condensed, water vapor behaves like a gas and is thus invisible, but the clouds of condensed water droplets refract and diffuse the sunlight and so are visible. The rate of evaporation is dependent on 6 factors. One is the vapor pressure of the water surface and air above. Second, air and water temperatures. Third, wind speed. 4, atmospheric pressure. 5, quality of water. 6, size of water body. Size of water body. And in the evaporation process, vapor pressure is the principal consideration. The rate is proportional to the difference between the saturation vapor pressure and the water temperature. So the saturation vapor pressure is represented by EW, and the vapor pressure at water temperature is E actual. So the evaporation in lake is considered in the formula equal to C, a constant value, multiplied by the quantity EW minus AA closed quantity. C is a constant, and our vapor pressure expressed in millimeter of mercury. The second factor on temperature, the rate of evaporation increases with an increase in water temperature. So this is just normal. The higher the temperature, the higher is the evaporation rate. Wind. The wind also aids in removing evaporated water vapor from the zone of evaporation and consequently creates a greater scope for evaporation. Atmospheric pressure. Other factors remaining the same, a decrease in barometric pressure as in high altitudes increases evaporation. Soluble salts. When a solute is dissolved in water, solute is the substance being placed in water for dissolution, no? Like for example, salt, no? So when a solute like salt is dissolved in water, the vapor pressure of the solution is less than that pure water and hence causes reduction in the rate of evaporation. The present the percent reduction in evaporation approximately corresponds to the percentage increase in the specific gravity. Thus, for example, under identical condition, evaporation from seawater is about 2 to 3% less than that of fresh water. Than that of fresh water. Now, another factor is heat storage in water bodies. Deep water bodies have more heat storage than shallow ones. A deep lake may store radiation energy received in summer and release it in winter, causing less evaporation in summer and more evaporation in winter compared to a shallow lake exposed to a similar situation. The amount of evaporated water from water surface is estimated by the following methods. The one is by the use of evaporimeter data. The second is by empirical equations. And number three, by analytical methods. So these are the three methods being used in order to measure evaporation. As I have said, gagamit tayo ng instrument like what we call as evaporimeter. Evaporimeter is that instrument used to measure evaporation rate. Then secondly, empirical equations. And three, actual measurements. We call that as analytical methods. Like for example, in the picture you can see there one type of evaporimeter. It is a tank with water inside and exposed to the atmosphere and subject to evaporation rate. The depth of water is noted in normally in the morning, 8 o'clock, and then take a reading again at 5 o'clock. The decrease in water inside the tank or the evaporimeter will give you the value of evaporation rate per day. Now, evaporimeters are water-containing pans which are exposed to the atmosphere and the loss of water by evaporation measured in them at regular interval. Meteorological data such as humidity, wind movement, air and water temperatures, and precipitations are also noted along with evaporation measurement. Estimation of evaporation is of utmost importance in many hydrologic problems associated with planning and operation of reservoirs and irrigation systems. In arid zones, this estimation is particularly important to conserve the scarce water resources. However, the exact measurement of evaporation from a large body of water is indeed one of the most difficult tasks. So, the different types of evaporimeters, you have this as the Class A evaporation pan, no? So this is a standard pan of 1,210 millimeter diameter and 255 millimeter depth used by the U.S. Weather Bureau and is known as the Class A land pan. The depth of water is maintained between 18 centimeter to 20 centimeter. As I've said a while ago, at 8, you get the reading, and at 5, you get again the reading. The loss of water will give you the amount of evaporated water per day. The second type of pan is the ISI, standard pan. This pan evaporimeter is specified by international standard in 5973 to 1970. Is also known as the modified Class A pan, consisting of pan whose dimension is 1,220 millimeter in diameter with 255 millimeter of depth. The pan is made of copper sheet of 0.9 millimeter thickness and thin inside and painted white outside. Then the third is the Colorado sunken pan. The pan is 920 millimeter square and 460 millimeter deep and made up of unpainted galvanized iron sheet and buried into the ground within 100 millimeter of the top. The chief advantage of the sunken pan is that radiation and aerodynamic characteristics are similar to those of a lake. However, it has the following disadvantages. It is difficult to detect leaks. And number two, extra care is needed to keep the surrounding area free from tall grass, dust, etc. And number three, it is expensive to install. The fourth is the U.S. Geological Survey floating pan. With a view to stimulate the characteristics of large body of water, this square pan, 900 millimeters side and 450 millimeters deep, supported by a drum floats in the middle of the raft, 4.25 meter by 4.25 meter, is set afloat in the lake. The water level in the pan is kept at the same level as the lake, leaving a rim of 75 millimeter. Now, in the computation of evaporation, it is always mandatory that based on the formula that you have seen, the evaporation is subject to pan coefficient because it is said there that evaporation pans are not exact models of large reservoir and have the following principal drawbacks. So because of that, we need to employ pan coefficient in order that the result will be somewhat realistic. Why? Number one, they differ in the heat storing capacity and heat transfer from the sides and bottom. The sunken pan and floating pan aim to reduce this deficiency. As a result of this factor, the evaporation from pan depends on a certain extent on its size. While a pan of 3 meters diameter is known to give a value which is about same as from neighboring large lake, a pan of size of 1 meter diameter indicates about 20% excess evaporation than that of 3 meters diameter pan. The height of the rim in the evaporation pan affects the wind action over the surface. Also, it casts a shadow of variable magnitude over water surface. The heat transfer characteristic of the pan material is different from that of the reservoir. In view of the above, the evaporation observed from pan has to be corrected to get the evaporation from the lake under similar climatic and exposure condition. Thus, the coefficient is introduced as lake evaporation is equals to the pan coefficient C times the pan evaporation, where C sub P is the pan coefficient and the values of C sub P is used in different pans are given in table 3.1. And the table is here. You have the classification of PAN 1 to 4, Class A, ISI, number 3, Colorado, USGS, number 4, average value for Class A is 0.70, ISI is 0.80, Colorado is 0.78, and USGS is 0.80. The range in PAN coefficient for Class A, 0.6 to 0.80, 0.65 to 110 for ISI. Then Colorado is 0.75 to 0.86. USGS is 0.70 to 0.82. Now this one is the average value. Now sometimes after discussing something on how we are going to measure evaporation by evaporimeters, now one should also know how to install evaporation in stations. Now you use the constant formulated by the World Meteorological Organization. Like for example, in arid zones, like the Philippines, we are in arid zone. One station for every 30,000 square kilometer. In humid temperature climates, one station for every 50,000 square kilometer. In cold regions, one station for every 100,000 square kilometer. Okay? Now, by the second method, we use empirical evaporation equation. So there are so many formulas that you can show here, that you can make use of. It says that a large number of empirical equations are available to estimate lake evaporation using commonly available meteorological data. Most formulae are based on Dalton type equation and can be expressed in the general form that E lake is equals to K times the function of U times EW minus EA. Well, EL is the lake evaporation in millimeter per day. EU, EW is the saturated vapor pressure at water surface temperature in millimeter of mercury. EA is the actual vapor pressure of overlying air at specified height in millimeter of mercury. The function of U is the wind speed correction function, and K ay coefficient. And K ay coefficient. The term E is measured at the same height at which wind speed is measured. Commonly used empirical evaporation formula are: 1. You have the Mayer's formula formulated in 1915 that evaporation in lake is equals to Km times EW minus AA times 1 plus U9 all over 16, where U9 is the mean velocity in kilometers per hour, 9 meters above the ground, and Km is the coefficient according to the other factors with a value of 0.36 for large body of deep water and zero point 0.5 for small and shallow waters. Then the second formula is the Rower's formula. And this Rower's formula considers a correction for the effect of pressure, addition to the wind, speed effect, and is given by E lake is equals to 0.771 multiplied by the quantity 1 plus 465 minus 0.00732 P star A closed quantity multiplied by open quantity 0.444 plus 0.0733 usable closed quantity to be multiplied by EW minus EA. Piece of A is the effect of pressure or the mean barometric reading in millimeter of mercury, and UO is the wind velocity in kilometers per hour at ground level, which can be taken to be a velocity of 0.6 meters height above the ground. In using the empirical equation, the saturated vapor pressure at a given temperature, often the wind velocity data would be available at elevation other than what is needed in the formula or in the particular equation. So you can apply a conversion factor that the wind speed at a certain height is equals to C times H raised to the power 1 over 7, where UH is the wind speed at a height H above the ground and C is a constant value. Sample: a reservoir with a surface area of 250 hectares and following average values of parameters during a week. Water temperature, 20 degrees centigrade, relative humidity, 40%, wind velocity at 1 meter above the ground, 16 kilometers per hour, and you are asked to estimate the average daily evaporation from the lake and the volume of water evaporated from the lake during that week. So, the solution is EW is a constant value being equal to 17.54 millimeter of mercury. Actual humidity times the EW, 40% of 17.5. That makes up 7.02 millimeter of mercury. U9, the wind velocity at a height 9 meters above the ground. So you convert that. U times 9 raised to the power 1 over 7. So that is now equals to 16 times 9 raised to the power 7. So you have 21.9 kilometer per hour. And then substituting that in the formula for mayors, 0.36 times the quantity 17.54. This is the value times E actual 7.02 multiplied by 1 plus U 9. Okay? 29.9 all over 16 equals to 8.97 millimeter of mercury. Evaporated volume in 7 days will be 7 times 8, 7 days times 8 over 9 over 1,000 times 250 times 10 raised to the power 4 conversion factor. So the result is 157,000 cubic meter, not square meter, cubic meter. Now, for the third type, the analytical methods of evaporation. The analytical method for determination of lake evaporation can be broadly classified in 3 categories. You use the water budgeting method. Second, the energy balance method. And third, you have the mass transfer method. Okay. So water budget, energy balance, and mass transfer. But here in our country, we normally make use of number 1, the water budget method. Yung energy at saka mass transfer, they are seldom used. So the water budget method, this water budget is the simplest of the 3 analytical methods and also the least reliable. It involves writing the hydrological continuity equation for the lake and determining the evaporation from a knowledge or estimation of other variables. Thus, considering daily average values for the lake, the continuity equation is written as P plus BTS plus BIG is equals to B out S plus BOG plus evaporation rate plus change in storage delta S plus T sub L, where P is the daily precipitation, BIS daily surface inflow into the lake, then BIG is the daily groundwater inflow, and then the daily surface outflow. Daily seepage, BOS rather, daily seepage outflow, then daily lake evaporation, EL, then change in storage, increase in lake storage in a day, and then T is the temperature, or no, not temperature, daily transpiration loss. All quantities are in units of volume, in cubic meter, or depth in millimeter over a reference area. The energy budget method, I just want to, you can just read that one, but this is seldom used because of the data that are being used. Like, for example, radiation, it takes a lot of sensitive instruments in order that you can be able to get all the data and supply that in the formula. That's why here in our country, this one is seldom used. But for purposes of our lecture, this is being introduced. At least you know that for analytical, there are 3, and the second one of which is energy budget method. The third you have the mass transfer. This method is based on the theories of turbulent mass transfer in boundary layer to calculate the mass water vapor transfer from the surface to the surrounding atmosphere. Okay, so that's it for the three methods. Evaporimeter, by the use of empirical formula in the third analytical methods. And next one is, since evaporation is a factor that affects water availability or water resource, at least one should know uh, the methods in minimizing or reducing reducing the amount of evaporation in lake. So any of the methods mentioned above may be used for estimation of reservoir evaporation, although analytical methods provide better result. They involve parameters that are difficult to access or expensive to obtain. Empirical equation can give approximate values of the correct order of magnitude. The water volume lost due to evaporation from reservoir in a month is calculated as BE is equals to AE PM times C sub P, where BE is the volume of water lost in evaporation in a month in cubic meter, A, the average reservoir area during the month, E, the pan evaporation loss in meters in a month, and A lake in millimeter per day times the number of days in a month, and C sub P, the pan coefficient. The various methods available for reducing or reduction of evaporation losses can be considered under three categories. The first method, you reduce the surface area. Of course, the smaller the surface area, the lesser is the evaporation rate. But these are only observed if you are going to construct man-made reservoir during the planning phase. Sa planning, you can already estimate the possible surface area by which the reservoir will be exposed to the atmosphere. So if you can find that area wherein less surface area but more depth, that's better because you can prevent evaporation, higher evaporation rate. So it is stated there that since the volume of water lost by evaporation is directly proportional to the surface area of the water body, the reduction of surface area whenever feasible reduces evaporation losses. Next, you make use of mechanical covers. You use permanent roofs over the reservoir, temporary roofs, and floating roofs such as rafts and lightweight floating particles can be adapted whenever feasible. Now, in our reservoir in NIA, we are already making use of the the LED LCD. We try to place it on top of on the surface of the lake to generate power. Kaya doon, we use that as mechanical cover at the same time reducing the rate of evaporation and at the same time generating power. So that can serve as mechanical cover and at the same time permanent roofs to reduce the area of surface area of the lake. We are already adapting this in our major dams like Pantabangan and Magat in Isabela, where mechanical covers are introduced in order to reduce evaporation rate. Then by the use of chemical films, This method is consists of applying thin chemical film on the water surface to reduce evaporation. The film form has to be the following desirable features. One, the film is strong and flexible and does not break easily due to wave action. Number two, if punctured due to the impact of raindrops or by birds, insects, etc., the film closes back soon after. And number three, it is pervious to oxygen and carbon dioxide. The water quality is therefore not affected by its presence. And the film, it must be colorless, odorless, and non-toxic. Normally, cetyl alcohol is found to be the most suitable chemical for use as evaporation inhibitor. It is white, waxy, crystalline, solid, and is available as lumps, flakes, or powder. It can be applied to the water surface in the form of powder, emulsion of solution, in mineral turpentine. Roughly about 3.5 Newton per hectare per day of cetyl alcohol is needed for effective action. The chemical is periodically replenished to make up the losses due to oxidation, wind sweep of the layer to the shore, and its removal by birds or insects. And evaporation reduction can be achieved to a maximum in a film of 4 times 10 to the power 2 Newton per meter is maintained. Okay, so that's all for evaporation. So the first part, as I've said, as to losses, it's all about evaporation. So we were able to learn how it is being measured, the factors that affecting evaporation, and the third is how to reduce evaporation in lakes by the use of mechanical cover or chemicals, film applied on the surface. And these are only the mandatory information that you should know. So that at least with respect to evaporation, not as meteorologists, but hydrologists and civil engineer, these are mandatory information that you should know. Not all function of engineers deals with construction of house, deals with construction and building. But if you are a water resource engineer, this will be the type of work that you will be doing. Like in my case, I am not classified as construction engineer, vertical construction engineer. We are on horizontal. We are constructing irrigation projects nationwide, no? So the construction of irrigation projects in dams is very much different from construction of buildings. Although in here, we are also constructing buildings, no? So we are also designing buildings. But the construction of dams, this design of dams is very much different from that vertical construction, like if you're going to construct buildings. Okay, the next topic will be evapotranspiration. So this is a combination of evaporation plus transpiration in leaf of plants. Okay, transpiration. It is the process by which water leaves the body of a living plant and reaches the atmosphere as water vapor. Evaporation compared to transpiration. In evaporation, it occurs when water becomes vapor from bodies of water. Evaporation continues all throughout the day and night. While transpiration occurs when water leaves a plant as a vapor. In transpiration is essentially confined to daylight hours. Evaporation and transpiration combined together will give you evapotranspiration. So you have evapotranspiration is transpiration plus evaporation. In the figure, you can see there the transpiration from trees and grass, evaporation, direct. Then you have the runoff here, the water. Then water penetrating down the soil will give you a complete groundwater recharge. No, this is a term used to describe the sum of evaporation and plant transpiration from the Earth's land surface to the atmosphere. The term that you must know for this evapotranspiration is the potential evapotranspiration. Potential evapotranspiration or PET is the amount of water that could be evaporated and transpired if there were sufficient water available. Actual evapotranspiration. It is the quantity of water that is actually removed from the surface due to the processes of evaporation and transpiration. How do we measure evapotranspiration? One is by the use of lysimeter. It is a measuring device which can be used to measure the amount of actual evapotranspiration which is released by plants, usually crops or trees. Then by the use of field plots, no? Evaporation is equal to precipitation plus irrigation input minus runoff minus increase in soil storage minus groundwater loss. This is the formula in order that we can be able to compute for evapotranspiration in field plots. Like for example in NIA, this is how evapotranspiration is being computed. Now, how do we compute for potential evapotranspiration? Potential evapotranspiration is computed by the use of Feynman's formula. The formula is given as PET is equals to A times HN plus EA times gamma all over A times plus gamma. No? That's the general formula. Where PET is the daily potential evapotranspiration in millimeter per day, A is the slope of the saturation vapor pressure as temperature curve at mean air temperature in millimeter of mercury per degree centigrade. Hn, the net radiation in millimeter of evaporable water per day. EA, the parameter including wind velocity and saturation deficit. Gamma is the psychrometric so constant equal to 0.49 millimeter. Hn, you use this long formula. Let me check the attendance if some are still there. No? Billion, will you please read the formula? Billion, are you there? Billion, billion, billion. Oh, billion is absent. Is number 4, non-register, no? But then I think he's already out. Billion, are you there?
Hello, sir. Hello po, sir.
Oh. Oh, will you please read the formula? Roy, can you see the PowerPoint presentation? Milien? Oh, hello? Hello? Milien, will you try to voice out? Ha?
Ito po sir,
Pakita.
HN is
Hmm.
equal to HA. Ito po ba sir?
Oh, you start because you say, oh, yan. Yan muna. Ang Penman's formula is, oh, will you please muna, yan.
So Pensman's formula is
Oh, diyan,
PET is equals to AH and plus EA Y is divided by A plus Y, where PET is equals to daily potential evapotranspiration in mm per day. A is equal to slope of the saturation vapor pressure as temperature curve at the mean air temperature in mm of mercury per Celsius. Hn is equal to net radiation in of evaporable water per day. EA is equal to parameter including wind velocity and saturation deficit. Y is equal to psychometric constant, and Y is equal to 0.49 mm.
hmm. Uh, from where are you, Milien?
Yes
Where's your
po.
location? Ha?
At Milor, sir, but we don't have internet ngayon, sir. Kawawala lang ng
Sa,
PLDT, sir. Milor po, Milor
sa
sa sir.
Milaor.
Wala lang po ng PLDT po kasi dito.
Ay, ay, ay.
Medyo not clear po
Can
pag
we
ano
try
siya
to
kadito.
call Binaid, Marisol? Okay, that's okay.
Sir.
Okay po, thank you.
Binaid? Binaid?
Yes po, sir. Hello po.
Pakibasa mo nga ng formula. What's your location right now?
Kalabanga po, sir.
Okay, pakikuan mo nga.
Penman's formula is PET is equals to H sub n plus E sub AY over A plus gamma, where PET is equals to daily potential evapotranspiration in mm per day. A is equals to slope of the saturation vapor pressure as temperature curve at the mean air temperature in of mercury per degree Celsius. H sub n is equals to net radiation in of evaporation water per day, and E sub A is equals to parameter including wind velocity and saturation deficit. Gamma is equals to psychometric constant, which is equals to 0.49 mm.
Okay, so for HN, that's the formula. Okay. HN.
H sub n is equals to H sub A times A minus R times the quantity of A plus B and N N over N minus AP times the quantity of 0.56 minus 0.092 the square root of E sub A times the quantity of 0. Plus 0.90 n small n over capital N, where H sub A is equals to incident solar radiation outside the atmosphere on a horizontal surface expressed in of evaporable water per day. R is equal to reflection of coefficient or the albedo. Usual range of values of R are given below. A is equals to a constant depending upon the latitude and is given by A is equals to 0.29 cosine theta. Cosine T. B is equals to a constant with an average value of 0.52. N is equals to actual duration of bright sunshine in hours.
Molen.
Capital N, capital N is equal to
Yeah.
maximum possible hours of bright sunshine, which is in table 3.5 po. And
Mm.
omega is equals to Stefan Boltzmann constant, which is
Sigma.
equals to 2.01 times 10 raised to negative 9 mm per day. T sub A is equals to mean air temperature in degrees Kelvin equals to 273 plus degrees Celsius, and E sub A is equals to actual mean vapor pressure in the air in mm of mercury.
Okay. So AA, again,
EA is equals to 0.35 times the quantity of 1 plus U sub 2 over 160 times the quantity of E sub W minus E sub A, where U sub 2 means wind speed at 2 meter above ground in kilometer per day. E sub U is equals to saturation vapor pressure at mean air temperature in gram of mercury, which is in table 3.3, and E sub A is equals to is actual vapor pressure. E sub U is equals to 4.584 exponential times the quantity of 7.27 T over 237 plus 3 237.3 plus T, where T is temperature in degrees Celsius.
so you have the first table there that will be using the formula. Okay. Will you please read?
Um, the and temperature is equals to temperature in degrees Celsius, the E sub U, mm of Hg, and A times mm per degree Celsius. Ayun, basahin ko pa po, sir, yung isa-isa.
Never mind. If it is 0,
If
EU
it is
is
0,
0.58, A is 0.30. No?
yes po,
So
sir.
5, you have 6.54, 0.45. So if the value of T is in between, you've got to interpolate. I just want to show to you the table for your reference. No?
Okay, sir.
Yan. Pakibasa naman ulit. Table
Table
3.4.
Table 3.4 mean monthly solar radiation at depth of atmosphere HAN evaporable water per day. For N latitude, and from January to December po yung naka-indicate. 0 degrees Celsius, January is, sample ano po ato?
14.5.
January is 14.5, on February 15.0, March 15.2, April 14.7, May 13.9, June 13.4, July 13.5, August 14.2, September 14.9, October 15.0, and November 14.6, December 14.2. Noticeable po na nag-change talaga yung ano.
Okay, so it is from 0, 10, 20, 30, 40. If the value is in between, as I've said, again, you've got to interpolate. Like, for example, the given latitude is, say, 12, like in Naga. So it is in between 10 and 20. So you've got to interpolate. Like, for example, the given month is March, no? So if it is March, this one is 14.8 to 13.9. So the value of 12 degrees north is in between these two values. So there is a need for us to interpolate. Table 3.5.
Table 3.5, mean monthly values of possible sunshine hours, or the N. And latitude 0 degree Celsius, 0 degree From January to December naman po, 12.1, 12.1, hanggang December na po siya 12.1.
Hmm.
Then, yung 10 degrees Celsius is from January to February, 11.6 and 11.8. From March to September po, nasa 12 degrees siya ganun. Iba-iba lang yung next digit.
Okay.
Then, okay na sir.
Sige, that's okay, no? So let us now apply it in a problem. Let's read.
Example 3.2. Calculate the potential evapotranspiration from an area in New Delhi in the month of November by Feynman's formula. The following data are available. The latitude is 28 degree and 4 minutes north. Elevation is 230 MASL.
What is that?
Temperature
230
is equals to
meters
200.
above sea level.
Okay po, sir. 230 meter above sea level. As
Then monthly mean temperature,
19 degrees Celsius. Mean observed sunshine hours, 75%. Wind velocity at 2 meters high, 85 kilometers per day. And the nature of surface cover, close ground green crop. From table 3.3, A is equals to 1 mm per degree Celsius. A sub W is equals to 16.5 mm of Hg.
okay. So how did we try to get that? Try to look back at uh, table,
Table 3.3.
yun. Okay? So from table 3.3, what is the given temperature? 19 degrees centigrade. So it is between this one, no?
17.5 and 20 po. Closest to 20 na siya.
Oo. Okay? So given EW here, 15 to 17.54. And then A, what is the answer there? It is approximately 1. So it is between 0.95 to 1.05. Do you know how to interpolate? Miss Binay? Ha?
Not sure sir, pero yung sa nearest ano na siya. Kung alin yung mas nearest ano sa kanya.
So first thing na ang una dyan is first get the value. Maybe others can do it, no? Get the temperature 0 degrees centigrade at 17.5. And then 20. Then you have, what is the temperature there given? 19. Okay? Get the value of A. What is the value of A at 17.5?
17.5, 0.95 po sir.
Okay, 0.95. At 19, you do not know the value. So you call that as X, no? So 20. Ano na po ninyo yan?
1.05 po.
1.05. Okay? So what's the difference between 17.5 and 20?
10 po sir,
2.5.
0.10.
No. 720 and 17.5.
Sir, maingay po dito. Paulit po ako sir. Pwede. Medyo
Anong
mainit.
difference between 20 and 17.5?
70
So it's 2.5, no?
po sir.
Then 19 and 20, you have 1.
1.
Yun naman sa 0.95 and 1.05 is point, ilan? 1.
Ay, opo, sir.
Tapos yung 1.05 and 1.05 in x. So you have x plus 1.05, no? So by ratio in proportion, you can now make the desired ratio. 1 is to 2.5 is equals to x plus 1.05. You can write it all over 0.1. Then compute for x. X is equals to 1. Compute for that. So 1 is to 2.5 is equals to x plus 1.05 all over 0.1. So the answer is 1. So at least you can practice it at home by interpolation because the other value will also be interpolated. Okay? Marisol?
Okay, sir. Okay po.
Okay. So, okay. Now what I want is please study this at home, no? Yan. Try to compute for the value using interpolation from table. Like for example, in table 3.3, the actual value of A by interpolation is 1 millimeter per degree centigrade. AW is 16.5. In table 3.4, H of A is 9.506. And table 3.5, it is 10.716. N over big N is 9 over 10.716 equals 0.84. Okay? So, paki-kwander. This will be your assignment, no? Try to restudy this at home and then please submit the detailed computation by next time. If you have some question, you can brought that out by next meeting. Is that okay? Is that class? Is that okay?
Yes, sir.
So, the main solution on the calculation of potential evapotranspiration by Pellman's equation is already here. But, i-assume natin ang kuwan, the first assignment will be the same given, pero papalitan nyo lang yung latitude. Gawin nyo yung latitude na 12 degrees, 30 minutes north. That is near Naga. So the problem now is calculate the potential evapotranspiration from an area near Naga City in the month of gawin yung March by Pellman's formula. Oh, yeah. Okay? Then the same. Palitan lang yung latitude, 12 degree, 30 minutes north, and then yung buwan, instead na November, gawin March. Okay? Gawin March. And then, please submit the solution next time. And then we will discuss it in the first hour. Is that all right? Huh? Is that all right?
Yes, sir.
Okay. So the solutions are already there. Yan, nandiyan na sila lahat. I-follow nyo lang. It is very difficult for us to discuss it here. So, try to recompute that at home. If you have some question, you can brought that out. Okay? You can brought that out. And ang assignment nyo will be palitan nyo yung kuwan, palitan yung latitude ng 12 degree 30 minutes north. That is already a place near Naga City. Tapos, ang month, instead na November, gawin March. Okay? They expect that there will be, then just make use of this guide solution. No. Yeah. So, in this case, the answer there is 2.224 millimeter per day. So, it's a very long and tedious process. But then this is the most common formula being used not only in the Philippines but worldwide to compute for the potential evapotranspiration. When we say potential, that is not the actual. Potential, assuming that temperature, pressure, humidity, and other meteorological parameters are in normal condition. Ano? Normal. Halimbawa, kung sa soil, the water is at saturated zone. Hindi under stress ang soil. No? It is saturated with water. Kaya, assuming kung sa kuwan sa tao basog, ano ang evapotranspiration rate niya? So, it is at maximum. If it is at maximum, that is the potential. Pero kung kulang, halimbawa dehydrated ang tao, then the potential evapotranspiration rate is low. That is actual. That is not the normal. But sometimes, actual na yan, pero that's the highest. That's the potential pa. It could be possible. Okay? Okay. So please continue, Ms. Binaid. So aside from Feynman's formula, we have the Blaney-Creedle formula. Will you please read?
Blaney-Creedle formula. A sub r is equal to 2.54 kf. F is equal to summation of P sub h, T sub f over 100, where AR is PET in crop section in centimeter, K is an empirical coefficient depends on the type of the crop, F sum of monthly consumptive use factors for the period, P sub H is equal to monthly percent of annual daytime hours, and T sub F is equals to mean monthly temperature in degree Fahrenheit.
Okay. So, then the next formula is the Thornthwaite formula.
Thornthwaite formula, which is ET is equal to 1.6 L sub A times the quantity of A 10 over I sub T raised to A, where ET is monthly PET in centimeter, L sub A is adjustment for the number of hours of daylight and days in the month related to the latitude of the place which is in table 3.8. T is mean monthly air temperature in degrees Celsius. I sub T is the total of 12 monthly values of heat and I is equals to summation of A1 in I, where I is equals to over 5 raised to 1.514. A is an empirical constant, which is equals to 6.75 times 10 raised to 7 I sub T raised to 3 minus 7.71 times 10 raised to 5 I sub T squared plus 1.792 times 10 raised to negative 2 IT plus 0.449 to 30.
Okay. So these two formulas is in addition to the Penmans. But we are using always the Penmans. But ito, mga empirical, sometimes this is also being used for to compute using lesser parameters, environmental parameters, no? But these are also being accepted. But in our case, in EA, we are using the Penmans to compute for the PET, the potential evapotranspiration. Okay? So let's now proceed. After evapotranspiration, let's come now to interception. Please read.
Interception. When it rains over a catchment, all the precipitation falls directly onto the ground. As it reaches the ground, a part of it may be caught by the vegetation and subsequently evaporated. The volume of water so caught is called interception. The interception precipitation may follow one of the three possible routes. One is it may be retained by the vegetation as a surface storage and returned to the atmosphere by evaporation, a process termed interception loss. Number two, it can drip off the plant leaves to join the ground surface or the surface flow. This is known as truthful. And number three, the rainwater may run along the leaves and branches and down the stem to reach the ground surface. This part is flow. Interception loss is solely due to evaporation and does not include transpiration, through fall or steam flow.
Okay, what do you understand by this? Marisol? What is interception?
Um, when it rains daw po, sir, hindi lahat ng water is napupunta dun sa catchment. Some po, mostly nga ata, pumupunta siya sa ground. Then, dun sa pag anong iyon, it may retain dun sa mga vegetation po, sa mga like plants or anything na andun sa ground na. Then, some might drift off from the leaves or might
Oh.
drift off po.
So, ang kuhan, hindi lahat ng tubig from rainfall na pupunta sa ground. And some of them are intercepted. No? So, because some of them are being intercepted, there are three possible roads na pwedeng mangyari. One, pwedeng ma-retain yan sa vegetation, hindi na makarating sa ground. Sa vegetation pa lang, it will evaporate, and if it evaporate, it is now called as interception loss. Kasi hindi na nakarating sa ground. Okay? Number two, it can drift off the plant leaves during the ground surface or surface flow. Yung nahulog sa ground is what we call as the through fall. Through fall. And number three, the rainwater may run along the leaves and branches and down the stem to reach the groundwater. Ang tawag nito ay stream flow. So there are three possible routes. One, it will evaporate. Number two, it will be a through fall. Or number three, it can be a stream flow. And interception loss is solely due to evaporation and does not include transpiration, through fall, or steam flow. Okay? Malinaw ba, Marisol?
Yes po, sir.
Kaya pag halimbawa may interception, tatlo ang pwedeng mangyari. Pwedeng mag-evaporate pa, it can be mahulog ulit sa ground through fall, and it will join rainfall, through this stem, it will be back into the ground through steam flow. But formerly, they were intercepted water. Okay? Sige, please continue.
The amount of water intercepted in a given area is extremely difficult to measure. It depends on the species composition of vegetation, its density, and also on the storm characteristics. It is estimated that of the total rainfall in an area during a plant growing season, the interception loss is about 10 to 20%. Interception is satisfied during the first part of the storm. If an area experiences a large number of small storms, the annual interception loss due to the forest in such cases will be high, amounting to greater than 25% of the annual precipitation. Quantitatively, the variation of interception loss with the rainfall magnitude per storm for small storms is as shown in Figure 3.7. It is seen that the interception loss is large for a small rainfall and levels up to a constant value for larger storms. For a given storm, the interception loss is estimated as capital I, small I is equals to Fi plus Ki E, where II is interception of loss in mm, SI is interception surge whose value varies from 0.25 to 1.25 mm depending on the nature of vegetation. Ki is ratio vegetal surface area to its projected area. E is evaporation rate and M per H or for R during the precipitation. T is duration of rainfall in Rs.
Okay. So, Javier, the interception loss curve, you will note that at the start of rainfall is 0 to 30. From start niya, the interception loss is too much. But as time goes on, after a certain value of rainfall has already increased, you will note that the interception loss is already decreasing. It becomes constant. Kaya kung at initial set, mas mataas yung interception loss based on this interception loss curve. Okay, we will ask another one. Thank you, Marisol.
Thank you, sir.
Can we call on can we call in tika, Arenas Donabel Arenas
Yes, sir.
Arena. Oh,
Yes,
pakibasa mo
sir.
nga.
Depression storage. When the precipitation of a storm reaches the ground, it must first fill up all depressions before it can flow over the surface. The volume of water trapped in these depressions is called depression storage. This amount is eventually lost to runoff through processes of infiltration and evaporation, and thus form a part of the initial loss. Depression storage depends on a vast number of factors, the chief of which are the type of soil, the condition of the surface reflecting the amount and nature of depression, the slope of the catchment, and the antecedent precipitation as a measure of the soil moisture. Obviously, general expressions for quantitative estimation of this loss are not available. Qualitatively, it has been found that antecedent precipitation has a very pronounced effect on decreasing the loss to runoff in a storm due to depression. Values of 0.5 cm in sand, 0.4 centimeters in loam, and 0.25 cm in clay can be taken as representatives for depression storage loss during intensive storms.
So what do you understand for depression storage, no? This the next. What do you mean by depression storage?
Kapag ano daw sir, nag yung nag-precipitate yung storm na tapos nag-reach sa ground, may
Ano ang
mga depressions
pakaintindi,
na kailangan
anong
i-fill.
pakaintindi mo na precipitation of a storm?
Nag-ano siya sir,
Ano yan? Ang precipitation of a storm is referring to changes in climatic condition.
okay po.
When we speak something of precipitation of a storm, yung precipitation there is rainfall, uran.
Mm,
Yeah.
yes sir.
Nag-uran niya. Nag-uran is one kind of storm, as they call it. Hindi bagyo yan.
Opo.
Yung precipitation of a storm. The storm that we are referring to in hydrology here is the abnormal condition of the atmosphere. In case there is rainfall, there is snowfall, or any changes in climatic conditions or systems of climatic like the occurrence of typhoon, like that. So the storm that we are referring to here is uh, the storm that we are referring to here is the what? The rainfall that we will be experiencing, depending upon the situation when it was formed. Yeah, naintindihan
Yes sir.
natin. O, sige. Please explain. O, kung halimbawa digdi, kunigwang ngayang, kung ang uran niya nakaabot sa ground, it must first fill up the depression before it can flow over the surface. O, malinaw na, naintindihan mo na.
Yes sir.
Ah, okay, o, sige, please proceed. Please explain further.
Yung depression storage daw sir, may mga factor siya na nakadepende. First is yung type ng soil.
Mm.
If sandy, loam, or clay, may different values po siya na equivalent doon. Tapos
Okay.
yung condition naman ng surface, tapos yung slope ng catchment, then yung soil moisture. Moisture.
Soil moisture. So, halimbawa, dyan, these are actually depression storage are low-lying areas, no? Kung halimbawa clay, and type of soil in the clay low-lying area, what can you expect? You will be having a pond, no? Pond, okay? And then the condition of the surface reflecting the amount. Halimbawa, no vegetation at all. So, what can you expect? You can be arriving at a stagnant area, stagnating water you have there. Kung slope man, madali naman siyang maalis. Pero kung talagang relatively flat, then all of the water will be in depression storage. Okay? So, will it be a part of groundwater? The answer is no, as if it is contained in a basin where it is not part of groundwater. So, in this case, it is not part of groundwater, but we call it as depression storage. Okay? Sige, please proceed. Donabil, infiltration.
Infiltration. Infiltration is the flow of water into the ground through the soil surface. The process can be easily understood through a simple analogy. There's an input of water, then there's a storage here, and there's a wire gauge, so there would be a spill there.
Mm. So what can you understand with the figure there? By
So pag
definition, is infiltration is flow of water into the ground through the soil surface. So it is the what? The entry of rainfall into the ground. Huh?
yes sir.
Oh. Ano sinabi diyan? The process can be easily understood through a simple analogy. You have a container, The input there is referring to rainfall. You have a wire gauge on top. Then there is spillage, no? So, infiltration, once the water will enter the storage, which is the ground, kung puno na, ano makakaroon yan?
May
Spill.
spill.
Yung nag-i-spill niya is already part of runoff. Ano? Pero yung nag-penetrate into the ground or storage, that becomes part of groundwater. While it is entering the surface, then we call that as infiltration. Hindi yung nakapasok na. Nakapasok is percolation, no? Deep percolation. While the rate of entry of water into the ground surface is infiltration. Maliwanag ba? Ah,
Yes, sir.
okay. Sige, please continue.
This analogy, though a highly simplified one, underscores two important aspects. The maximum rate at which the ground can absorb water, the infiltration capacity, and the volume of water that it can hold.
Hmm. Okay? Hmm. So, ano naintindihan mo dyan?
So may dalawang important aspect daw yung based on the analogy ng container and the input and the spillage. So may capacity lang yung ground na kaya niya ma-absorb ng water and may volume lang ng water na kailangan siyang kaya niyang i-hold.
Yeah. Like your stomach, if you drink water, your stomach will be filled with water, di ba? If you continue drinking and your stomach is already full up to your esophagus, what will happen to the water? It will no longer be accepted inside, di ba? So it will spill out. So the capacity that it can maximum holding capacity of your stomach is your infiltration capacity, no? Di ba? It's like soil. Soil has also its infiltration capacity, which is referring to the volume of water that it can sufficiently hold. Okay? Hmm. Sige, please continue.
Infiltration capacity. The maximum rate at which a given soil at a given time can absorb water, designated as F of C and is expressed in units of centimeter per height or per H. The actual rate of infiltration F can be expressed
Centimeter
as
per hour.
per hour. Okay, so
Yeah.
designated as F of C and expressed in units of centimeter per hour. The actual rate of infiltration F can be expressed as F is equal to F of C when I is greater than F of C, or F is equal to I when I is less than F of C, where I is equal to the intensity of rainfall.
Halimbawa, ang field capacity ay 10. Ang infiltration ay greater than 10 din 12. No? Oh, 12. Oh, you substitute. The infiltration capacity, F is equals to F of C if I is greater than F sub C. Di ba? So, if 10 is greater than 12, the field capacity is only up to its limit, which is 10. What will happen to the 2? Run off na. Ano? Yung kaya niya lang. Ang kaya niya lang is only 10, the capacity. So, the excess will be run off. Contrary to the second assumption, ano yung second assumption? F equals, read,
Is equal to I when I is less than F of C.
ano yan?
If the intensity of rainfall is greater
Ang
than the
F
field
is
capacity.
equals to I. Halimbawa, ang I again is 8. Ang capacity niya is 10. Sabi kanina. So, ang capacity niya will only be equal to I. Kasi kaya, papasok lahat, di ba? So, the 8 can be accommodated in 10. So, therefore, the intensity is less than the field capacity. Kaya kung ang intensity is less than field capacity, ang infiltration rate is equals to the field capacity. All water will be taken in by the soil. Okay? All water will be taken in by the soil. Ang example kanina, ang I ay 8, ang infiltration capacity ay 10. So I is equals to F, which is 8 only, hindi 10. Kasi wala nang kuwan. All water will now be taken in. No more excess. Okay? Please continue. So you have an infiltration model there. Okay, the infiltration model, the low intensity rainfall, the surface runoff, high intensity rainfall, too much excess. Okay, then you have also the second model, the soil moisture storage capacity, then the percolation to ground water, then no contribution to groundwater, and then to groundwater flow. So these are the illustrative model that may happen in case infiltration of water in the soil is taking place. So it's either situation 1, 2, 3, 4, 5, or 6. So pwede kayong magpili dito sa 6 na situation na mangyari sa infiltration rate. Okay. Please continue.
Characteristics of soil. The type of soil, sand, silt, or clay, its texture, structure, permeability, and under drainage are the important characteristics under this category. A loose, permeable, sandy soil will have a larger infiltration capacity than tight, clayey soil.
Okay. So I think that is self-explanatory, no? So, sige nga, i-explain mo nga yan. Can you possibly explain that? Kaya niyo yan? Doon na ba?
Based on the figure, sir, there is a rainfall rate, which is depth over time, and an infiltration capacity, which is depth over time. So when the rainfall rate is greater than the infiltration capacity, the difference is the runoff, same as in the equation that we have previously
Okay.
saw. And from the infiltration capacity tells us how much of the rainfall can be absorbed by the ground without running out. So this is the illustration of the equation.
So that is the illustration of the two general equations. Correct. Right. Yan.
The filtration is equal to filtration capacity if the infiltration rate is greater than the filtration capacity. And the filtration is equal to infiltration capacity if the infiltration capacity is greater than the filtration capacity. So if the storage is greater than the infiltration capacity, then we will use the infiltration capacity as the F. And if the infiltration capacity is greater than the filtration capacity, then we will use filtration capacity. And the excess will be run off.
Okay. Sige. Sige. Please proceed.
Measurement of infiltration. Information about the infiltration characteristics of the soil at a given location can be obtained by conducting controlled experiments on small areas. The experiment setup is called infiltrometer. There are two kinds of infiltrometer, the flooding type infiltrometer and the rainfall simulator.
Okay. Did you discuss this in your soil mechanics? Are you through with soil mechanics?
Not yet, sir.
Wala pa kayong soil mechanics na subject? Wala pa?
Geotech 1 pa lang po.
Wala pa. Pero this is one of geotech subject. But anyway, so to measure infiltration rate, you have two kinds of device. Ang device on instrument na tawag niyan ay infiltrometer. So ang infiltrometer is the instrument used to measure infiltration rate. And there are two kinds of infiltrometer, flooding type and then the rainfall simulator. Sige.
The flooding type infiltrometer. This is a simple instrument consisting essentially of a metal cylinder 30 cm diameter and 60 cm long, open at both ends.
Oh. Oh, yan itong una, walang ring. Kaya pag nag-infiltrate ang tubig, ano magkuhan? May lateral. Ano? Bakong
Yes.
direkta. Pero kung may ring sa gitna, diretso. Ano? Dito sa labas, yan, ang iguang kuhan. So the value inside will not be affected so much because of the ring that is placed inside. No? So that's the difference between the flooding type. The double ring and then the single ring. Ayan, nakita nyo. That's, yeah, makikita nyo yan dyan. Okay? This one is the single ring, while this one is the double ring. And the ring inside. The first ring and then the outer. The second ring. Kaya ang tawag natin ay double ring. Okay. Please continue.
Main, main disadvantages of flooding type infiltrometer. The raindrop impact effect is not simulated. The driving of the tube or rings disturbs the soil structure, and the result of the infiltrometer depend to some extent on their size, with the larger meters giving less rates than the smaller ones. This is due to the border effect.
Okay. Next type.
Next type is rainfall simulator. This is a small plot of land of about 2 meters by 4 meter size, is provided with a series of nozzles on the longer side with arrangements to collect and measure the surface runoff rate. The specially designed nozzles produce raindrops falling from a height of 2 meters and are capable of producing various intensities of rainfall. Experiments are conducted under controlled conditions with various combinations of intensities and durations, and the surface runoff is measured in each case.
Okay. So in rainfall simulator, as you are simulating the rain through the use of a hose, a shower bulb, something like that, wherein the rate of flow is estimated to simulate the effect of rain. As in the second paragraph, it says the specially designed nozzles produce raindrops falling from a height of 2 meters and are capable of producing various intensities of rainfall. Experiments are conducted under controlled condition with various combination of intensities and duration, and the surface runoff is measured in each case. So ito parang actual na, no? But is this advantageous compared to the first one? Yes, this is more of an advantage, but not so practical, no? For our feasibility study, we just make use of the first one, the double ring and the single ring infiltrometer instead of the rainfall simulator, no? Okay. Please proceed.
The infiltration capacity values. Horton, express the decay of the infiltration capacity with time as F of Ct is equal to F of Cf plus F of C theta minus F of Cf multiplied by e raised to negative kHt, where Fct is equal to infiltration capacity at any time t from start of the rainfall. FCO is equal to initial infiltration capacity at t is equal to 0. FCF is equal to final steady state value. T is equal to duration of the rainfall, and Kh is equal to constant depending upon the soil characteristics and vegetation cover.
Okay, so the infiltration capacity values gives you the decay of infiltration capacity with respect to time. Yun. So, at the start of rainfall, halimbawa, ito ay sandy loam, mataas, no? Ang infiltration niya mataas. Pero, as time goes on, nagiging constant. For clay loam, mayroon naman. Sandy loam, you have that also. Clay loam, yan. So, ano ang pinakamataas na infiltration capacity? Sandy loam. Sand. Itong clay medyo mababa because of they are fine. Kaya sinasabi dito, it is apparent that infiltration capacity values are subjected to wide variation depending on the large number of factors. Like a bare sandy area will have 1.2 centimeter per hour while a baked clay will only have around 0.15, mababa lang. A good grass cover or vegetative cover increases the values of such 10 times the arrive value. Kaya may vegetation cover, lalong mataas. So what can you expect of infiltration? So vegetation is now being used by civil engineer to control flooding, no? Flooding through improvement of vegetative cover on mountains. Kaya ngayon, what's the solution of flooding? Is it by construction of infrastructure facilities? No, it is because of this. We increase the value of infiltration capacity by improving grass cover so that we can increase infiltration rate and minimize surface runoff. That's the ratio or the essence given by this uh, PowerPoint. No? Okay. Please proceed.
Infiltration index. In hydrological calculations involving floods, it is found convenient to use a constant value of infiltration rate for the duration of the storm. The average infiltration rate is called infiltration index. It's derived from the rainfall hydrograph with the knowledge of the resulting runoff volume. If the rainfall intensity is less than theta, then the infiltration rate is equal to the rainfall intensity. However, if the rainfall intensity is larger than theta, the difference between rainfall phi.
That's phi,
Okay.
phi. Not
If
theta.
the rainfall okay, sir. If the rainfall intensity is less than phi, then the infiltration rate is equal to the rainfall intensity. However, if the rainfall intensity is larger than phi, the difference between rainfall and infiltration in an interval of time represents the runoff volume.
Okay, isa-isahin mo. Yung una. In hydrological calculation involving floods, it is found convenient to use constant value of infiltration rate for the duration of the storm. The average infiltration rate is infiltration index. Maliwanag. Kapag sinabi natin na infiltration index, that's the average infiltration rate. And is derived from rainfall hyetograph, no? Hyetograph is a plot of rainfall versus time with the knowledge of resulting runoff volume. If the rainfall intensity is less than the rate, phi, then the infiltration rate is equal to rainfall intensity. Kung mababa, lahat na absorb ng ground. Pero kung ang intensity ay malaki, isa sa index, yung ina-absorb ng ground. Okay? The difference between rainfall intensity in an interval of time represents the runoff volume. Ano? Kaya yung sobra, that will give you the runoff because only a portion is absorbed by the ground. That's the significance of determining the infiltration index so that we can be able to approximate how much water was absorbed by the ground and how much water did contribute to runoff. Okay. Next, hyetograph.
Hyetograph, a chart or graphic representation of the average distribution of rain over the surface of the Earth. It is the graph time versus the depth.
Okay, hyetograph is a plot on, discuss na natin yung una, di ba? A plot of rainfall intensity versus time, no? Rainfall versus time. Or, like for example, in this case, rainfall intensity. Yan. This is time. 0, 2 hours, 4 hours, 6 hours, 8 hours, 10 hours, 12 hours, 14 hours. Then this is the rainfall intensity. First 2 hours, 0.5. Tapos tumaas ng, let us say, 1.25. Okay? Then tumaas sa 2, bumaba dyan sa 1. Tumaas sa 2 plus, bumaba dito. Itong kuan, this is now runoff. Those that were absorbed by the ground is only this one. This is what we call as the Phi index or the infiltration capacity, no? So the rest ng rainfall ay part ng runoff already. Hindi na kayang i-absorb sa ground. So this is, the Phi index is this one, the water that were absorbed by the ground. Assumed to be on the average, no? And then the excess will be runoff. Okay. Example. Sige, pakibasa.
Example, a storm with 10 centimeter precipitation produced a direct runoff of 5.8 centimeter. Given the time distribution of the storm as below, estimate the P index of the storm. So the time from the start, it's in hours. So we have 1 to 8 hours. And the incremental rainfall in each hour, we have 0.4 on the first hour, 0.9 on the second hour, 1.5 on the third, 2.3 on the fourth, 1.8 on the fifth, 1.6 on the sixth, 1.0 on the seventh, and 0.5 at the eighth.
Okay. Sige. So, solution?
So the solution, we have total infiltration is equal to 10 minus 5.8, and it's
What's
equal to 4.2 centimeter.
Saan ka kumuha
Then
ng pakibasa niyo? So dito, the storm with 10 centimeter precipitation produce a direct runoff of 5.8. No. So total infiltration, total minus runoff will give you infiltration, di ba?
yes,
Huh?
sir.
So you have 4.2. Assume the time of rainfall excess, 8 for the first trial. So phi is 4.2 divided by 8.525. Assume 6 hours for the second trial. 10 minus 0.4 minus 0.6 minus 5.8, you have 3.3. Where did we get 0.4? Ha? Alisin mo ito. Kasi 6 hours lang. 1, 2, 3, 4, 5, 6. So you exclude 0.5 and 0.4. No? First hour and then last hour. So going back, so you have 10 minus 0.4 minus 0.5 minus 5.8. So you have 3.3 centimeters. So 3.3 divided by 6, you have now 0.55 centimeter per hour. So time from start, if you adopt the second, time from start, you expect that there was no infiltration or rainfall excess. Lahat na absorb ng ground. Nagkaroon ng excess only on the second hanggang 7th. On the 8th, wala na. So the rainfall excess will be 5.8 centimeter, which is equals to the total runoff. Okay? Total runoff. Sige. So in an attempt,
In an attempt to refine the fee index, the initial losses are separated from the total obstructions, and an average value of infiltration rate called the W index is defined as W is equal to P minus R minus I infinite over T uh, phi. P is equal to total storm precipitation in centimeters. R is equal to total storm runoff in centimeters. I infinity uh, I alpha is equal to initial losses in centimeter. T phi is equal to duration of the rainfall excess. Uh, in example, the total time in which the rainfall intensity is greater than W and R's, and W is equal to average rate of infiltration in centimeter per hour.
okay, so this W index is another formula that is used to define the rainfall excess, no? The rainfall excess using W index. The other one is by the use of P index. Okay? Oh, yan. So, you are given here the type of soil, the coefficient alpha, no? In estimating the maximum flood for design purposes in the absence of other data, P-index of 0.1 centimeter per hour can be obtained. Yan. Kung wala. Okay? Sige. Thank you very much, Donabel. No? Okay. So that ends our lecture for today on abstraction from precipitation. To recap what we have done for abstraction, we have, as I have said, evaporation, then evapotranspiration, interception, depression, storage, and infiltration. So all these five were already discussed, and these are abstraction. When we said abstraction, where will the water go after occurrence of rainfall? Some will evaporate, some will undergo evapotranspiration through plants, some will be intercepted by vegetation or buildings, some will be in depression storage, while the others will infiltrate into the soil. Okay, so that's it for the topic, but I want to give emphasis blackboard, no? With your name and then the corresponding solution to this kind of problem detailed with interpolation. Then you are to calculate the potential, the problem given will be calculate the potential evapotranspiration from an area near Naga City. Okay? Paki-kwen yun, Naga City. Please write for the month of November. For the month of, instead of November, March. By Penman's formula. Okay? The following data are available. Latitude, 12 degrees, 30 minutes north. Elevation, instead na 230 meters above sea level, you will use at least 2.3 meters. 2.3 meters above sea level. Okay? Mean monthly temperature is supposed to be 25 degrees centigrade. 25 degrees centigrade. Okay? Wind velocity, mean observed sunshine hours, lagay nyo ay 8. 8. Then, wind velocity, 85 kilometers per day. Okay? Then, nature of surface cover, close ground, green crop. Okay. So, you will try to solve this. Ang pagbabago lang, yung latitude, 12 degree, 28 degrees instead of 28, 12 degree 30 minutes north. Elevation binago natin 2.30. Yung iba, yung mean monthly temperature gawin yung 25. Yan lang ang pagbabago. Ang pagbabago, mean monthly temperature 25, elevation 2.3, latitude 12 degree 30 minutes north, then March, okay? Month of March, na place, Naga City. Okay? Is that clear? Huh? Is that clear?
Yes, sir.
Yes, sir.
Okay. You are going to submit the detailed computation next time. For the first hour, we will be calling on someone. Maybe, do you know how to present your work to the blackboard, or you want to share your solution? Can it be possible? May I ask the class? Do you know how to share your assignment to other groups? Share screen? Can you do it? Oh, anybody?
No, sir.
Hindi nyo kaya. Hindi kaya. Kasi halimbawa, mayroon kang ipipresent, isi-share mo sa screen, then, halimbawa, nakakonek ka dyan, ma-permit ka sa akin, ibigyan kita ng kuwan, you will be permitted to share your screen, yung solution yun makikita dyan. Can be done. No? But I just don't know. Because normally when we are having our virtual meeting in Mindoro, because our participants are in Palawan, Mindoro Oriental, in Manila, so we are always talking through virtual conference. So we are fond of sharing screen so that at least we can see the data that you have and then that I have so that we can compare. If that is not possible, maybe tawagan na lang natin and then we will guide you. Okay? Any question? Any question? Huh?
None,
Okay.
sir. None po.
Oh, sinong kwan? Oh. Do you think you can do some calculation on interpolation? Tignan nyo na ito para makita natin next time, ha? The solution is there and I hope you can you can do your work. Please submit your work as I have said recitation here, your attendance counts a lot. Like today, there were so many late. Yung late ngayon will only be rated 1/2, as if you were absent already for 1.5 hours. Those that entered after 8:45, we are going to mark that as late. You are only present for 1.5 hours. There were so many lates that entered beyond 8:45. Kaya hindi ko na nag-check ng attendance because I will keep on calling, repeatedly keep on calling. So, ang ginawa ko ngayon, halimbawa, ang pinakaunang nag-register, si Binaid. Pangalawa, si Narosa. Number 3, sa Balyege. These are the persons who registered before 8. Bilyen, Jaime, James, Castro Verde, in order. Kaya, hindi nyo sinasabi dito na kuwan. If you are on the last part of my list, that goes to show that you are really late. Ito siguro ang magandang paraan para makita natin whether you are religiously attending the class on time. So if your name is always beyond 9 p.m. 9 a.m., that goes to show that you are not interested in passing. Hindi na huwag tayo mag-assume dito na kuwan. Baka hindi ko naman kayo bigyan ng grade, no? Unlike the other class, the other year, ito, hanggang ngayon, wala na yun. So, although no grade, sinasabing SIP, the grade is still in progress, pero pag wala yung completion within 1 semester, that is good as 5. There were 7 students who did not comply. So in this case, as I've said, your attendance counts a lot, no? Kinukuha ko yun. So if your attendance is 5/5, meaning no late, that's 100%. Pero halimbawa, ang attendance mo ay 5, always late, lumalabas dyan ay 50% lang. Okay? So I hope you registered early. Saka hindi naman sa pagkuhan. Pag nagre-register kayong late, parang nadi-disturb yung presentation. Ha? So, yan pa. Maraming students who has left the meeting. So I see to it that I consider that, no? I consider that. Pwede naman kayong mag-register earlier. I understand the situation through virtual, but at least if there is a proof or showing that there is really a problem technically, then I consider that. But if it is already intentional na lumalabas na, kita naman kasi routinary. If you are always late, you will always be on the last. You will always be on the last. Meron nagkakamit, hindi naman malakas ang internet. Why not put it in a chat? I can consider that. Sir, I cannot register earlier because of internet problem. Okay? Nilalagay nila ang iba eh. They make use of other students who registered earlier. O sir, ganito, mahina ang internet. I take note all of these things. Okay? Kaya ayaw ko lang because I am a little bit frustrated today because more than half of the class registered beyond 8:45. And I marked them all late. Whether it is debatable or not, I mark them all late. Okay? It is my prerogative. Ano? Pero makikita naman natin. Kasi karamihan dito, pig-analyze ko, yung palaging late na yung time ng pagpasok, ganun pa rin. ganun pa rin. I'm sorry for making a comment. Kaya I sometimes I consider all other technical problems, but there are some students who are always registering late. Hindi naman technical problems yon. Kasi yung location nila ay nasa magandang kabubuan area wherein internet is not a problem. But I recognize kung mayroon man. Okay? So, any clarification? Ha? Any clarification? Oh. So, when you say, Sir, I'm late today, there's no need for you to have the attendance check. Ang ginawa ko ngayon, i-record yung time in nyo. So, that's why, in order na yung kwan. So, there is no need for me to say that you are late. So, yun ang kwan. Any question? Any kwan? I am open to questions before proceeding.
Sir, excuse me po.
Yes.
Nung ano po sir, nung first meeting po sir, nag-chat po ako nun sir ng present po ako sir. Kasi po late na rin po ako sir naka-register kasi di ko po alam sir na may meeting po pala. Late ko din po nalaman na may meeting po pala nung first meeting. And nagsabi po ako sir nung second meeting po natin na present po ako. Absent pa rin po yung nakalagay sa blackboard ko.
Okay, you can place it in a chat there so that I will analyze that later, no? Yeah, you are so many, you are more than 40. So if ever you have a problem or exceptional problem like that, i-chat nyo lang and then we will look into it.
Saan po sir i-chat?
Diyan, sa kon mo lang, ilagay mo lang ngayon. You can, may chat nga ng iba dyan. Sabi niya, Sir, mahirap ang internet namin dito. But I already take note of your name, John Vincent.
Thank you po sir.
Pag nagsalita ka, automatic, I write it. Kaya, halimbawa, yun, may nagchat dyan. Ngayon nga, si Dila Torre, kasasabi ko niya, nakikita ko yun because this one is being recorded. So, for your information, I normally have this one recorded so that at least if there are some questions, I can make use of this as a sort of kuan. Yan. So, Radabya, wala pong kuryente sa kanila. Ayun. I can see that also. Pag ganun, automatic pinipicturean ko yun. O, paano mawawala yun? Eh kung wala naman kayong ganun, how can I know? Diba? It's only you who can know the details, no? So, dito naman, ilalagay lang natin because maybe sa karamihan nyo, only very few are doing well. Normally, yung mga nauna dito nagre-register are really good in class. Okay? Pero yung iba na ayaw naman siguro, gusto pang magtagal sa engineering, maybe we can give them another year to stay. Diyan, Sulweta. Sir, every Sunday po, walang kuryente sa Naga. Oh, anong gagawin mo? Kung walang kuryente sa Naga, hindi ka na pala papasok. Di ba? There are other ways by which you can go on, no? Kung walang kuryente sa Naga, what's the solution? You have also alternatives. No? Alam nyo, my daughter is in Kanaman right now. She is having also her virtual class, medicine at that. Sometimes there is no current in Kanaman, but kung wala siya, hindi silang pinupunta niya, pumupunta siya sa Starbucks o kaya kung saan dyan. Just only to attend the class, no? So it's not the technicality that counts, no? Kaya hindi naman pwedeng sabihin because may kwander. May kwander, may kwan naman tayo dito. No? Paki-repeat nga yun, paano yung naka-time in? Sino ba yun? Hindi ko nakita. Will you please have it seen again? Who was that? Will you please voice out? Hindi ko nakita. Sir, paano yung naka-time? Cell forte in early pero na-disconnect. Na-disconnect. Bakit na-disconnect? Alforte, are you there? Alforte.
Sa internet po, sir.
Oh,
Wala po ang internet.
oh, wala namang problema. Ganyan, nakakapagsalita ka nga ngayon.
Opo,
Di balik
pero
kang
kasi
mawala.
po,
Basta pag nawawala ka, ang mahirap lang pag nawawala na, ayaw nang bumalik.
sige po,
Di
sir.
ba
Sige po, sir.
nakikita naman
Salamat po.
dito, may nakikita naman dito, ang dami-dami ngayon nawala. Pero I understand, but yung mga nawawala, hindi naman lahat nawawala, pero bumabalik ka agad. You just want to correct. And I can also be corrected. Kasi nahihirapan tayo dahil virtual. Not like face-to-face, walang problema tayo. But we've got to help each other so that at least this problem of pandemic era will not be a hindrance to the conduct of the class. Di ba? I hope it's not only me. You should also cooperate, no? Kaya, halimbawa, I am encouraging each and everyone to register before 8. Because I will no longer tolerate. Magkaroon tayo ng cut-off time. Next time, pag 8:30 wala, late na yun ang nag-register. Ngayon, pig-cut off ko ng 8:45, no? Ang dami. Almost half of the class, no? Okay? Sige. Iba talagang nahuli. Kung tulog man, kaya nakataon lang kasi yung mga mahilig dito mag-inom. Mahilig mag-inom, yan. Kaya si Nino Gonzales, I promise daw, ako sir, dahil nagiinom. Si Manrique, matutubod ka kayong si Manrique ah. Si Manrique, magtanong ka nga ni Manrique. Manrique, are you still there?
Yes, sir. I'm here.
Oh, nagiinom ka pa. Nanganang ka
Kaya na,
naman.
sir.
Ha?
Occasionally na lang, sir. Kaso pero may okasyon.
Oh, di Perminatoro ka 2:00 ng maga.
Hindi man, sir.
Kung sila nga
May
siguro,
mga sir.
kapag ka pang turog.
Yeah.
Sige. Okay, that's all. Yan lang ang observation natin, no? So we hope that we can do away with all these things, these problems. Let us help together, at least by solving the problem together, because this is a virtual class. At least I know where to stand. I know kung anong gagawin ko para kung kaya ginagawa ko ngayon, pinababasa ko, at least I can see if others are still there. Kung ako lang magsasalita, pag naka-in kayo, hindi naman kayo nakikinig, paano kang malaman na nandiyan kayo? So I want to call on somebody else. But sometimes my line is also cut. Kaya that's a proof also na at least nandiyan tayo. Okay? Any more problem? Okay. So we are already through with dito sa yes. Yeah. With your name. With your name. Hindi na sa email kasi may hirapan din ako. Ha? No more. No more yung learning activity. No more. Yan lang. Okay? So any more question? Wala na. So if there are no more questions, next meeting, please study. We will discuss at least 2 chapters next meeting, yung stream flow measurement and part of hydrograph. I just don't know kung hanggang kailan tayo. Hanggang kailan ba tayo? Anybody? How many more Sundays do we have? Dalawa? Hello?
Dalawa na lang, sir.
Dalawa, no? Ang kailangan is matapos natin yung hydrograph. So within 2 weeks time, then after that, tapos na. So kayang-kaya natin ito. So next time, precipitation in part of hydrograph, and the last will be kuwan. After hydrograph floods, that's the end of it. Hanggang kailan? Hanggang kailan ang kwenta natin?
Hanggang
March.
29 daw po, sir.
Ha?
March 29 daw po.
March. March ano? Ang kuwan?
March 29 daw po ang end ng cluster 1.
March 29. Okay. So, mayroon pa tayong dalawa. Okay? Sige. Kaya pa yun. So, next meeting, we will start at exactly 8, no? Exactly 8 mag-start tayo. Ngayon, supposed to be mag-start tayo, pero it seems that you are a little bit tired already. Pakigawin nyo na lang yung assignment nyo, and then do some advanced reading on discharge measurement, no? Discharge measurement and part of hydrograph. So that will be our last lecture for 6 hours, and we hope that we can do it. Okay? Yung exam natin, normally ang exam ay nasa last meeting. Is that so? Donabel? Donabel?
Sir, yes po.
Donabel? Last meeting. Sige, we are going to have it scheduled. Yung kuwan, para wala tayong problema. Okay? But any more question?
Sir, magsisend pa po ba nitong presentation sa BB?
Yung dito, ito? Wala pa kayong
Opo, sir.
kopya?
Ito pong...
Wala pa kayong
po,
kopya?
sir.
Can you,
Wala pa po.
dina-download nyo yung book by Subramanya? Dina-download nyo? Libre naman Na-download nyo yun? Hindi. Sino yung nagsasalita? Whom I am talking to? Sino? Hello?
Binaig po, sir. Binaig
Oh.
po, sir.
Bakit hindi kayo? Pwede naman kayo
Hindi po,
mag-download
sir.
yung Engineering Hydrology by Subramanya. Nandyan yung lahat. Ano? Engineering Hydrology
Po, kasi
by
ako nung una, sir, wala po.
Ha?
Wala po akong nakuhang free nung last time na pag-search ko.
You try again because may free yan, no? Please try again, no?
Sige po, sir. Maghahanap
Anyway,
na.
we just kwen nyo lang.
Okay po.
We will resolve it next meeting, no? Okay, any more question?
Okay po. Thank you.
Okay, kung wala na, let's call it a day. Good morning once again. Thank you very much for attending the class. I will no longer check the attendance who are late because inisa-isa ko na from the first to register up to the last person who registered. Any more question? Wala na? Okay, thank you very much
Bye, sir.
and good morning. Thank you. Thank you.
Thank you, sir.
Thank you, sir.
Thank you
Thank
po,
you.
sir. Thank you, sir.
Yes, sir.
Okay.
Bye-bye.
Present ako, sir.
Happy Sunday, sir. Thank you.
Thank you. Thank you.
Bye, sir.